So good evening to all. So I am Dr. V. Sharmila. I am going to explain basics of theory of computation. So introduction to finite automata. Finite automata are abstract machine used to recognize patterns in input sequences. So it consists of states, transitions, and input symbols, processing each symbol step by step. If the machine ends in an accepting state, after processing the input, it is accepted. If the machine not ends in an accepting state, after processing the input, it is rejected. So finite automata can be represented by input tape and finite control. So input tape, first one, input tape. Input tape is a linear tape having some number of cells. Each input symbol is placed in each cell. Finite control. So finite control decides the next state on receiving the particular input from input tape. The tape reader reads the cell one by one from left to right, and at a time only one input symbol is read. So this is finite automata model. Input tape recording the input symbol, input tape divided into number of cells. Each cell capable of storing one input symbol. Finite control moves from left to right. It reads one symbol at a time. So definition of finite automata. Generally, finite automata consists of 5 components or 5 tuples. That is, finite automata, that is machine M equal to capital Q summation delta Q naught F. Here, Q represents finite set of states. Summation represents finite set of inputs. Input symbols are alphabets. Q represents initial state. F represents set of final states. Delta represents transition function. That is, here delta takes 2 parameters as an input and produces the 1 parameter as a output. So transition symbol delta equal to Q into summation equal to Q. So here Q represents current state. Summation represents inputs. It takes current state and input symbol as a input and produces the next state, that is Q into summation equal to Q. That is, Q represents next state. So after receiving the input symbol, machine moves from one state to another state. This is transition. Types of finite automata. So finite automata can be divided into 2 types. That is deterministic finite automata, non-deterministic finite automata. So first one is deterministic. Deterministic means the control is deterministic. That is, it moves only one state for each input symbol. That is deterministic. In DFA, for each input symbol, the machine transitions to only one state. DFA, that is deterministic finite automata, consists of 5 tuples. Q, set of states. Summation, set of input symbols. Q, initial state. F, set of final state. Delta, transition function. That is, it is defined as delta equal to Q into summation equal to Q. That is, here for each input in DFA, the finite control moves from one state to another state after receiving the input symbol. That means, so it moves only one state for each input symbol. Next, non-deterministic finite automata. Non-deterministic means machine, it moves more than one state. Sometimes it moves more than one state for each input symbol. That is multiple states. It moves multiple states for each input symbol. It consists of 5 components. That is NFA, NFA equal to Q summation, capital Q summation delta Q naught F. Here Q represents set of states. Summation represents set of input symbols. Q initial state, F final state. Transition function delta defined as Q into summation equal to 2 power Q. Here 2 power Q represents multiple states. Here non-deterministic automata, moves more than one state for each input symbol. That represents 2 power q. 2 power q means it moves more than one state for each input symbol. Thank you.